although this topic on monsoons looks pretty innocuous, but it is actually not. Now, when you are going to be dealing with this topic, explain how various factors influence the origin and development of the Indian monsoon system. You are going to be taking into account two factors, two independent factors. One of them is the origin, and the other, of course, is going to be the development of the monsoon. So the first thing lies in the comprehension of the question. That is, you're not going to be talking about the mechanism in the sense that is what happens in December, January, what happens in the winters, what happens in the spring, what happens in the summer, and what happens in the autumn. You're not going to be talking about it. What you are going to be talking about it is what are the factors, how is it that you're going to explain? Explain means how is it that you're going to simplify it. This is what it means by explanation in this case. So in what manner is it that you can go to simplify it by talking about the development of the Indian monsoons. And how is it that once developed, monsoons start moving from one place to another place. That means from one region to another region of South. To begin with, the topic goes on to be catering to different aspects. The first is, why is it that this question was asked? Now, this question was asked largely because there have been a lot of research associated with the temperature of the Arabian Sea, temperature of Indian Ocean in general. And there are a lot of new findings which explained why is it that the monsoons go on to be so intense over Kerala and over the entire of the western coastal region. The intensity of the bursts of the monsoon have been increasing, and consequently that spurred up a new research in the temperature of the Indian Ocean, particularly the Arabian Sea region, which was responsible for the question being asked in this case. This is a very mark-fetching topic, particularly this one largely because of two reasons. The first is you are going to be talking about factors, and supposing there are going to be 10 factors or 12 factors, and you have written all of them. There is no scope of marks being deducted out of it. And supposing you have to make something like some 10, 11 diagrams associated with it, again, there is no scope of marks being deducted out of it. Now, in both of these cases, the topic goes on to be very, very marks fetching. This is one of those type of topics which can go to help you yield no less than something like some 80 to 90% marks easily. And the approach is that in this case, how diagrammatic that you can go to make it. You can go to draw not 1, not 2, not 3. Imagine you can go to draw not less than something like 10, 11 diagrams associated with this topic. The problem that you are going to face is, or the problems that you can go to create for yourself is that because you are going to be making diagrams, mind it. When you go to make diagrams, it is easy. It is easy because you go to think like you can go to explain it. But if the diagrams are wrong, then that is fatal. That is really fatal. This is largely because you expose yourself completely in front of the examiner. And you show that, well, you have tried to make the diagram, but your diagram is not correct. So, the danger with diagram is that when you go to make it, it must be 100% correct. Otherwise, it will go to spoil your image in front of the examiner, and that is where the caution lies. Now, this is one of those topics that you can go to find being presented in different forms in different places. Of course, these are the sources that have been given to you. But coming to the topic, there are two parts of the monsoon. When you are going to be talking about monsoons, there are going to be two parts about which you have to talk of. One of them is going to be northeast monsoon. The second is going to be southwest monsoon. Northeast and southwest, both of them go on to be having certain type of an origin. The northeast monsoon are those type of monsoons which after a high pressure system that has been developed over these regions, they find their way outside the whole of India in this manner. These are the winds that move after high pressure has been accentuated in this region in all the parts. Now, as they go on to move towards this region, this is the place where they're going to pick up moisture. And because they're going to pick up moisture in this region, consequently, they are responsible for, because they're going to pick up moisture from here, they become involved in a weak cyclonic disturbance over these regions. And because they have become weak in terms of the cyclonic disturbance, they're going to organize themselves in the form of a major rainfall system in the whole of a southeast part of the country. Southwest monsoon, in contrast, they are spurred by a low pressure system that has been developed over this region, and to fill this low pressure system, winds come from all the directions: Arabian Sea region, Bay of Bengal region, as well as from Pacific Ocean. Although this mark has not been made it out, but then when you are going to be talking about the monsoons, you have to talk about both of these branches of the monsoons. That is where it is going to be significant. Now, coming to picking up the first part of it, the southwest monsoon. The southwest monsoons are those monsoons which are associated with the development of a low pressure system over these regions. That's the place where you have a low pressure system developed. And to fill this low pressure gap, this is how the winds go on to move. And then another winds happen to be coming from the Pacific Ocean that is going to be trying to fill, which is called as the ITCZ, Intertropical Convergence Zone. That is by definition southwest monsoon. Northeast monsoon they originate largely because of the high pressure that is developed in the wake of the jet stream subsiding over these regions. And it is from here that the winds started moving in anticyclonic form. These are the high pressure systems as jet streams go on to move, and they allow the winds to move in such type of direction. And when they're going to move in such type of direction, that is where they're going to pick up moisture. So the monsoons are going to be determined by thermal conditions. It's winter, and consequently the air is dense, air is heavy, and that air sinks, and that is responsible for formation of a high pressure over these regions. And low pressure in the summers because the temperatures are high over these regions. The second is the movement of the ITCZ. That is, the ITCZ starts moving from, imagine that is going to winter condition. This is the presence of the ITCZ. That's ITCZ, and ITCZ has gradually started moving all the way. In this case, that is going to be denoted by a different color line. That's how exactly ITCZ starts moving. This is the way, and then it has got itself established in these regions. This is the place where the ITCZ is now established. That is the movement of the ITCZ. And the third is the subtropical jet stream. This is the place where the subtropical jet streams are present. That is the region. And these subtropical jets, they're going to get bifurcated into two parts over this region. The southern part of the jet stream, this is the southern part of the jet stream, that keeps on bringing high pressure condition in different zones. And these high pressure conditions are responsible for the movement of these winds. Now imagine this diagram. The one diagram that has been given to you is going to be incorrect, because not from everywhere that the high pressure is going to be developed. High pressure keeps on changing and keeps on getting itself fluctuating. So sometimes it is going to be towards the northwestern region, then it is in the Gangetic plain, then it is going to be in these regions. The whole of this region is going to be in general dominated by the high pressure. These are the three factors in this case. Thereafter, there are going to be different type of factors that will go on to affect the monsoons. Now these factors will go to comprise of all of those factors that we are going to be talking of. One of them is going to be MLPT. Now, MLPT is another name of the ITCZ, but then it is going to be called by the name of monsoon low pressure trough. And imagine it, what exactly happens in this case. This is the way that the ITCZ starts moving into India. That is the way. And a time comes when the ITCZ establishes itself over the whole of almost over the entire of the Gangetic plain zone. This is the place where the ITCZ starts establishing itself. Now, this place where it has established itself in the form of intertropical convergence zone, it is a low pressure zone, and that is going to be called by the name of monsoon low pressure trough, MLPT. This is the name that is going to be given to it, MLPT, monsoon low pressure trough. This monsoon low pressure trough invites winds. It is this monsoon low pressure trough that goes into invite winds because it's a low pressure zone. It is these that goes into invite winds from every possible direction. Now there are two aspects associated with the MLPT. One is that it invites winds. The second is that it keeps on fluctuating. Fluctuating in the sense that sometimes it moves over north, sometimes it moves over south. So it is a quasi-stationary. It's not completely stationary. It keeps on fluctuating, sometimes established over Himalayan region and sometimes over the Gangetic region in this case. Now, picking it up in form of another diagram, that's where you're going to understand it, that's where you're going to find it. This is a monsoon low pressure trough. So sometimes it can go to be here, sometimes it is going to be towards the southern region. So in every place, monsoon low pressure trough will go on to bring rains. So all along it will go on to bring rains. Supposing it is going to be established over the northern portion, all along the foothills of the Shivalik, then in these regions, in this place, what it will go on to do is, it will go on to bring a good amount of rainfall and the Gangetic plain will go on to become completely dry. That's going to be one. And if it is going to be towards the southernmost side, then again the whole of the Plateau region, particularly as much amount of an extension that is going to be possible, that will going to receive a very high amount of rainfall, while the northern portion will going to become completely dry in this case. So that is going to be one of these factors, MLPT, monsoon low pressure trough. The second is going to be Macarenas High in Somali Jet. Now picking it up in this manner, you will go on to understand its value a bit better. We are going to be talking about this zone, Macarenas High. Now Macarenas High is going to be, that's the place where Macarenas High is there. That's the place. The whole of this region is going to be called by this name, Macarenas High. Now, the better the location of Macarenas High, in this case, let's say, that's the place where you're going to be having this location of Macarenas High. The more will be the outflow of the air away from this zone. The greater will be the amount of outflow away from this zone. So development of Macarenas High is going to be significant because this is the place from where the monsoons go on to begin, originate. In a sense, the southwest monsoon originate from this place. That is going to be one of these factors. Now go on to pick up the second one, that is going to be Somali Jet. It's going to be all about those zones, those type of jet streams which develop and that go on to move from here onwards. This is the place of the origin of the Somali Jet. That's the place from where the Somali Jet goes on to originate. That is the place where it goes on to blow. This is how exactly that it goes on to move and goes on to blow in that place. It is this Somali Jet, if you can go to consider direction, that carries the same direction as that of the southwest monsoon. That is responsible for taking the winds away from this region and towards India. That is where you're going to find winds moving towards India. That is where you're going to find these winds moving towards India. And if that is going to be India, it is going to be crashing against India. This is Somali Jet. Somali Jet is responsible for providing a certain degree of a force to the monsoon. The winds started rising from the same place, from because of the Somali Jet. You again pick it up, that is the third case, that is going to be the heating of the Tibetan High and the Tropical Westerly Jet stream. Coming on to this component of it, you find that there is a very strong component of winds that go on to blow. The Tibetan plateau goes on to get heated, and that is responsible for generating such type of a flow. This is the type of a flow that is going to be generated all in all. This is the way that the flow is going to be generated over the whole of India. And that is because of the heating of the Tibetan plateau region. You will go to understand it with the help of another of this diagram. This is where the Tibetan plateau is, the entire of the region is going to be. Tibetan plateau is going to be intensely heated because of two factors. First is that it is very, very high. And because being very high, the air being very rarer in this place, it allows the winds to rise over this place. That goes on to lead to formation of a low pressure over this region, and the winds go on to rise from here. That's reason number one. The region has to get itself heated in order to allow the winds to rise from here. The second is on the rim, this is the rim, at the rim of the Tibetan Plateau region, all along the rim of this Tibetan Plateau region, there is going to be good amount of rainfall prior to the origin of the monsoons. And this is because there is going to be a certain amount of, all along, certain amount of moisture-laden winds that go on to find their way in this zone. Now, the greater the amount of rains, the greater is the release of the latent heat of energy. And the greater the latent heat of energy is, the greater is the heating of the Tibetan Plateau. And once the plateau goes on to get heated, then that is where, that's the place from where originates what we're going to be calling it as a tropical easterly jet stream. And these tropical easterly jet streams have a component to follow. And the component that they tend to follow in this case is going to be very different all in all. And that is something that we can go on to understand. Now, after getting heated, this is how the jet streams go on to move. They hover around over India in such a manner. That is the way that they go on to hover around India. That's the way that they keep on moving from here. Now, moving in such a manner, they have two responsibilities to follow. The first is that they do not go on to allow in this place, this is the place that they do not go on to allow any type of tropical cyclone to form in the Bay of Bengal region. And supposing a tropical cyclone has formed, that means that the tropical easterly jet stream is not going to be very strong. Now, if it is not going to be strong, what will be the impact? That it is responsible for allowing these winds. We are going to be talking about all of these winds. That is Somali jet stream. The winds which happen to be coming from the eastern coast of Somali. These are the winds that are going to be coming from this region. All of these winds they do not go on to strike India with that much amount of force. So the force goes on to be absent. That means there are two forces that are responsible for making southwest monsoon striking western part of the country strongly. One is Somali jet stream, and of course other is the return flow of the tropical easterly jet stream. That is going to be another factor. There is going to be a third factor, an important factor, that is the heating of Tibetan Plateau in tropical easterly jet. That is going to be El Nino. Now, El Nino has a major role to play, and of course before that it is going to be bifurcation of the jet stream, and that is where the jet streams go on to function. This is the place. That is we are going to be talking about these jet streams. This is one jet stream. This is going to be another jet stream over India. That is where you have Africa in this case, and they are going to get bifurcated because of the Tibetan Plateau. And this bifurcation has two impacts. It is responsible for bringing what we are going to be calling it western disturbances into India. That is one. The second is they are the ones which are responsible also for accentuating the high pressure condition that exists in these regions. So high pressure exists because of the bifurcation of the jet stream, the southern part of the jet stream all in this case here. Of course, then other is going to be El Nino. Now El Nino refers to you will going to understand it that normally what happens is this is the normal condition. This is a normal year, and that is going to be an El Nino year. In a normal year, the entire of this region, the whole of this region goes on to be having a low pressure. This whole of this region will go to have a low pressure, and these regions go on to be having a high pressure. So winds from these regions go on to move all the way towards these regions. The water is also going to be warmer in these regions, and when they're going to come to here, it is these winds that go on to enter into India. This is the way that they're going to enter into India. These winds, and they're going to bring a good amount of rainfall. But in an El Nino year, the conditions go on to become completely different. What happens is the whole of the process goes on to get itself completely reversed. And this is the place that goes on to develop a low pressure. And this is the place that develops a high pressure. So the winds start moving from here onwards, and they start moving towards South America. Now that means that The amount of rainfall that normally goes on to be taking place here, these are the places where the amount of rainfall was very high. Now that is going to be completely suppressed, and that goes on to affect India. It is going to take place, take it into other phenomena. This is what happens in El Nino. That is, normally these are the winds that are going to come, and it is here. It's in the southern portion or the eastern portion of the Pacific that the winds start rising. Convection takes place. And the place where there used to be a low pressure, this is the place where there used to be low pressure. Now it goes on to, because the winds are going to be subsiding, that goes on to lead to high pressure. Low pressure is absent in this region. That affects it, and that's a normal air condition in this case. That is, in normal air, all of these winds will go on to come here, they will go on to move, keep on moving here towards Indonesia, and then rise, and then go to sink and subside. Now that goes on to get disrupted. The other aspect is what we go on to be calling it by the name of Indian Ocean Dipole. Now Indian Ocean Dipole, you can go on to understand it, it goes on to be having two conditions. So what we're going to be calling it is a positive one, and that is going to be called as a negative one. That's going to be one condition, and that you're going to understand it. That's going to be second condition, that's going to be a third condition. Negative phase, then you have a positive phase, and this goes into be accumulation of both of these. It is basically refers to the difference in ocean temperature between East and West Indian Ocean. That is, this is the western part of Indian Ocean, this is the eastern part of the Indian Ocean. So if the eastern part of Indian Ocean is going to be cooler ocean is going to be there, that will reduce convection, where the air will not be rising and there will be no chance of rainfall at all. So that goes on to bring good amount of drought condition to Australia, and Australian people do not go on to like it at all. Of course, that is the relationship India has with respect to Australia. That's one. Second is, as you can go to think about it, this means that the entire of this region goes on to become warmer than normal. And because that region is going to be warmer than normal, this is the place that the air starts rising, it starts moving upward, and it goes on to make a complete circulation of sinking and subsiding in these places where there is going to be a cooler air. Now that goes on to be good condition for India. The difference in ocean temperature between east and west, they can go on to alter the atmospheric circulation. You can go on to find this taking place in a negative manner. Now that is going to be a warmer water. Warmer water means this is the place that is going to be having heavy rains. And the entire of this region is going to be normally cooler waters, and that will going to have less amount of rain, and the whole of this region will be having a low amount of rainfall condition. Now in another condition, that is the entire place goes on to become completely cool, and in response to that the whole of this region goes on to become completely warm. And because it's going to become warmer, it goes on to lead to, from here it will go on to lead to a good amount of moisture content of the air. This air will go to move into this direction, and consequently will go to lead to heavy rainfall, not only over India, but over all of these adjoining regions like Yemen, Pakistan, and some portions of Somalia as well in this case. That is called as Indian Ocean Dipole. The other is going to be called, at the last of this factor that affects his monsoon is going to be Madden Julien circulation. Now Madden Julien circulation is effectively one type of a circulation which is again associated with the upward motion of this air. And how is it that the whole of the system keeps on moving towards the east? That this upward motion keeps on moving towards the east. And in normal condition, as you can go to say it, if the air is going to be rising here, the system is moving towards the eastern region. That is where the system will go on to move. And as this system keeps on moving towards the eastern region, it keeps on bringing high amount of rainfall. And as this system stops, again the region will go on to be having a high amount of rainfall in that place, which you can go to understand it from this diagram. That's where you're going to find it. That's North America. This is where is Southeast Asia. That is the place that we're going to be calling it by the name of Southeast Asia. The whole of this region is Southeast Asia. This is the area that we are going to be concerned with. That's the area that concerns us. And that is an enhanced phase. Enhanced phase, that means this is the place where convection is taking place. And the entire system keeps on moving towards the east. And Then as it moves towards the east, it goes on to be suppressed. In an enhanced phase, Madden-Julien circulation is always going to be leading to a high amount of rainfall over India. So, Indian monsoon is not going to be simple. Indian monsoon is complicated enough to be affected by thermal conditions, by the ITCZ, by the subtropical high pressure belt, by all of those conditions that we have talked about so far, comprising of what not in this condition. That is beginning with thermal conditions, movement of ITCZ, subtropical westerly jet, and then MLPT, monsoon low pressure trough, Macarenas High, Somali Jet, heating of Tibetan Plateau, and tropical easterly jet stream, El Nino, or even ENSO event, Dipole, Indian Ocean dipole circulation, and Madden-Julien circulation. Now, once you have been able to put so many of these diagrams in so many ways, there is no way that your marks can be deducted in this case. You are bound to get very, very heavy marks.
To have more such discussions and analysis, subscribe to our channel and hit the bell icon for notifications on our upcoming videos.